Hi, welcome to my channel Cloud with Girish. In this video, I'm going to show you how to build a serverless image resizing solution with Python, Boto3 and AWS S3 Lambda trigger. There are many business use cases that may ask for storing image thumbnail based on the original images uploaded by the users. Range of business use case may include online photo albums, bank storing check images, auto dealer storing auto images, and online inventory, ordering system, and so on. With cloud, storage is cost effective and easy to allocate. However, with ease comes the shared responsibility model of the cloud. FinOps, as you hear, is becoming very popular. One of the best practices is to understanding usage and cost of your cloud resources. Let's discuss this in the context of thousands of images you may have to store and how to create a serverless solution to automate the creation of reduced size images for immediate use. AWS storage used this in example is S3. Lambda is used to process the image and another S3 bucket is used to store the reduced size images. Let's look at our business use case. User will upload an image in AWS S3 bucket. A Lambda function will process the image to a reduced size. This reduced size image will be stored in another S3 bucket. Image in the source AWS S3 bucket will need to be deleted. What size image should be reduced should be configurable using environment variable. AWS S3 source and target bucket can be configured using environment variable. Event-based processing, Lambda should be triggered each time an image is uploaded to source S3 bucket. I will be creating the Lambda function via infrastructure as code approach using AWS Serverless Application Framework and CloudFormation. However, you can create the Lambda function using the AWS console as well. SAM is a powerful tool for developers to develop and test Lambda function and API endpoint locally, validating and then deploying to the cloud. If you want to learn about creating and testing Lambda function using AWS SAM, please watch my video on Lambda workshop. Link is in the description for this. Let's look at our architecture design. As you can see in this diagram, we have a source bucket and we have a target bucket created in S3. User will upload the original image to the source bucket, which will trigger an event. This event will invoke a Lambda function, and Lambda function is using the Python, Boto3 and Pillow library to get the original image from the source bucket, create another image of reduced size and upload this reduced size image to the target bucket. Once it's uploaded to the target bucket, the original image from the source bucket will be deleted and CloudWatch log will be updated. Let's get started. Prereq for this workshop is familiarity with AWS console, knowledge of Python Boto3, knowledge of AWS S3, knowledge of AWS Lambda, and basic familiarity with event-driven design and architecture. We will create a source S3 bucket, we'll create a target S3 bucket, we'll review the AWS SAM template, then we'll review our Lambda function, we'll build the function locally using AWS SAM, we'll invoke the function locally using AWS SAM, and then eventually we'll deploy this function using SAM framework. We'll create a source S3 bucket and Lambda trigger. We'll upload an image. We'll review the target S3 bucket, and then we'll review the CloudWatch log. So let's create the source S3 bucket. Create S3 bucket named as source bucket GB. You can change other setting or leave them as default and create the bucket. I'm leaving all other settings as default. Let's create a target S3 bucket, and I'm going to name it as target bucket GB. Again, you can change the setting or leave them as default and create the bucket. Let's review the AWS SAM template. We have a function name here, which is image resizer, and there is a handler. I'm using a Python 3.1.12 runtime. Timeout is 15 seconds. My memory size is the default 128 MB, and then I have environment variable for source, target bucket, and the image size per our use case. Let's look at the Lambda function. Lambda function is retrieving the object key, which is the image name, and once the image is retrieved from the source bucket, we are calling a resize image function, which takes the image and the size as the parameter and return a reduced size image. This reduced size image is then getting uploaded to the target S3 bucket. I'm building the function locally using AWS SAM, using the SAM build command. As you can see, the build succeeded. So I can move on to the next step, which is basically using another SAM command to locally invoke this Lambda function. I'm invoking it locally, and then once it passes my validation test, I'm going to deploy it using AWS SAM, and command for that is SAM deploy. Now my function is deployed in AWS cloud. I'm going to create a trigger. So I'm going to go to my source bucket and add a trigger. I'm going to, once my trigger has been added for the Lambda function, I'm going to upload an image. So let's upload an image, and this upload will trigger the Lambda function. Function for the code will load a reduced size file to the target S3 bucket. Now my function has been invoked. Let's review the target S3 bucket. As you can see that a reduced size file has been added to the target bucket, and original file is deleted from the source bucket. CloudWatch log, it will show the log message per our Lambda function code. With this workshop, a serverless image resizing solution with Python Boto3 and AWS S3 Lambda trigger has been successfully completed. You can create an alternate use case where you choose to move the original image to a long-term S3 storage bucket like S3 Glacier rather than deleting the image from source S3 bucket. Employing strategy to optimize your cloud resources and control the cost should be a high priority for any cloud organization. Hope you enjoyed this tutorial. I'm working on some other interesting content on various AWS topics. These will be posted soon. Please don't forget to like and subscribe. Thanks for watching.